Hi guys, welcome to this tutorial. Today I'll be showing you how to write musical melodies in C language. Just to make my life easy, I've already written down a few sets of codes already in Turbo C. These are basically the three header files we'll require, which is stdio.h, conio.h, dos.h. And in my void main loop, I've already written down these three functions. One is sound, which is going to be our main function that will produce the frequencies we want. The other is delay, which will basically give a time delay between each and every statement. And no sound simply means, well, it will stop the sound. So yeah, how this works is I just have to mention, in sound I just have to mention the frequency I want to produce. So right now I want to produce 300 Hertz, so I'll mention 300 Hertz. In delay I mention the millisecond delay, which basically means that it will play the 300 Hertz tone for about 300 milliseconds, and then there will be no sound. So let's try and run this program. This is what it sounds like. Yeah, a bit boring, but that's the basics. To make this more interesting, well, I can basically loop this. So I can add a for loop, I equals 0, I plus plus, and suppose I want to repeat this tone say 4 times. So I just write I less than 4. So it's gonna start from 0 to 3 and then that's it. So int I. Now what will happen right now is it will first produce the tone, it will wait for a while it's producing the tone, and then it will stop the sound, but instantly it's gonna produce the sound again. So just to make sure we have a small gap of silence, we can add another delay of 300 microseconds. Now this will basically repeat the 300 Hertz tone 4 times. So let's try it out. Yeah, that works. Now, just to make life a bit simpler, I'll replace delay with this variable called clock. And I'll replace the frequency with the variable called loop. So let's just declare these two, float root and int clock. Right. Now, to play a sequence of notes, suppose I already know what frequencies I want to play, I just need to declare an array. So let's call it, let's make it a float value. Let's call it note, and in this array, I'll write down 4 random frequencies. And okay, right. So I've written down these 4 random frequencies, and instead of root, I'll write down note I. So what's gonna happen is when I is 0, it will play 283 Hertz, and then it will play 485, and then 766, and then 102. It's gonna play this sequence of notes. Let's try it out. And that did not work. Why not? Well, simply because I haven't mentioned the clock. So it actually played those frequencies, but it did it so fast that we couldn't hear it. So let's call it 300 and okay. Right, so 4 random notes. To make it a bit more musical, rather to produce frequencies that are conventionally musical in our 12-note chromatic scale, we need to follow certain rules. Now there are certain ratios that are followed in the chromatic scale. So if suppose your root frequency is 300 Hertz, and let's just assume that is C, then C sharp is going to be 300 multiplied by 1.066, and so on. And so there are basically all these different decimal numbers we need to multiply our root frequency with to produce all the 12 notes we require in an octave. So I'll just write down an array and fill it with these numbers. I'll call it mult, as in the multiplier. and in this multiplier array I'll just write down these frequencies. Now these ratios. Now these ratios are actually in decimal places, so I'll just multiply 1000 just to prevent any kind of rounding off that might take place inside the CPU while it's compiling this program. So yeah, let's just write these ratios down. So 1000 and 1066, 1125, 1200, 1250, I guess. Yeah, 1250, 1333, 1414, 1500, 1600, 1666. The next is 1750, and the last note is 1833. So these are the 12 ratios you require to produce the whole chromatic scale. And now if I just have to write a loop that will basically multiply the root frequency with these multipliers and save it in the note array. So let me just remove all these extra frequencies from here, and the note is gonna have 12 notes for now, since we're just gonna be using one octave. If you want more than one octave, well, you can go with more notes. Okay, let me show you how to do it with 2 octaves. So yeah, 24 notes, that's what we require. I'll write another for loop, and in this loop the counter will go from 0 to 12. So I less than 12. And the statement is gonna be note I. So basically that specific note is gonna be equal to root into the multiplier. So mult, not curly, square braces, mult I divided by 1000. Divided by 1000 simply because, well, I had multiplied the ratios with 1000, and just to be a bit on the safer side, I'll just add these braces. So it first multiplies the number with the root and then divides it by 1000. And I guess that is done. But you see, note actually has 12 notes. So to produce the remaining 12 notes, I just have to say note I plus 12 should be equal to, well, note I times 2. Okay, let me explain this, why I've written I times 2. See, what happens is, each and every octave is basically twice the previous octave's frequency. So suppose A4 is 440 Hz, then A5 is going to be 880 Hz, just twice the frequency. Similarly, A3 is going to be 220 Hz and A2 is going to be 110 Hz. So to get the next octave, you just have to multiply every whatever note you are on, you just multiply that by 2, and that will be the next octave. So yeah, that's how you can produce as many octaves as you like. You can produce the whole 8 octave range, or you could use the 4 octaves we usually use. I guess that will work. Let me just mention the root frequency here. I'll continue with 300 Hz, and let's play all these 12 notes. I think, yeah, this is it. So now what's going to happen is each and every note from in the chromatic scale is going to be played in an ascending order. And why have I written 12? Let's write 24. Let's listen to the whole 2 octaves. Okay, let's run this program. Right, so that works. Now all you need to do is write down a sequence of semitones or fret number for the guitarists out there. So suppose I want to play the tune right. So and okay, I haven't mentioned the variable type. So int, and instead of note I, I'll write sequence I. So now it's gonna play the 0th note, which is gonna be the root note, and 3 times, and then it'll play the 3rd note, and then the 5th note, and the 7th note, and so on. Basically, it's gonna play that sequence of semitones. So let's try it out. Okay, let me actually remove this, since now the sequence is of only 8 notes. And why just write 8? I think I'll call it sequence length, and I'll declare this variable outside the void main loop. Int sequence length. Okay, that's not an array, and that's that, and that is 8. So now we have, okay, so basically it's gonna play these 8 notes. Let's try it out. Yeah, that sounds a lot more melodic than the previous stuff I had shown you. Let's increase the clock speed. Now it's 50 milliseconds, so it's gonna, each and every cycle is gonna be about 100 milliseconds. Let's play this. Right, so that sounds a bit more interesting. Now, why just play it once? Let's increase the number of times this will be played. So I'll add another loop, and this time let's call it y equals 0, y plus plus less than, and let's declare a variable called repeat, PEAT, right. I close this block, and yeah, that perhaps is okay. I need to declare these 2 variables. So y and int repeat, right. So, and let's just repeat this 4 times. So now the sequence will be repeated 4 times. Let's run this. And that's basically it. That's how you can basically make any tune you feel like. This is just by adding this multiplier array, you can make your notes a bit more, rather frequencies a bit more musical. And yeah, that's that. So these are the things you can play around with. You can play around with the root frequency. You can play around with how fast each and every note is going to be using the clock variable. You can play around with what's the sequence gonna be. You can play around with what's the sequence length and how many times you want to repeat the sequence. And that's that. If you've got any other ideas, well, email me or write down in the comment section. Like this video, perhaps share it, and yeah, that'll be it, I guess. Thank you.